Now we are ready to implement the push function. By the way, let's check why I have an error message here. It seems Visual Studio Code syntax check error, so let's close it and open it again. Then the error disappeared. So push function, the algorithm we have learned is as follows. Here we first we add a new node at the end and then compare with the parent and the swap if it's so a parent is smaller. So that's the algorithm. So keep this picture there. So let's implement push void heap push data is there. Then first step is we need to add a new leaf node. So that is elements vector, and the push back is the one. Let's give just the 0 and then default. We need to specify any value, so let's give a 0, and then this one is added with a value 0. Then what is my index? Index of the one just added is elements size minus 1 is the index of the last element just added. Then what you need to do is demote parent of index if the parent is smaller than new data. So that's the algorithm. So basically what you want to do is if parent value, my parent value is less than the data to be inserted, then we need to store the parent value in the vacant position. So the element just added, pushed back is elements and in my index. So that's the last one just added. Then parent should be stored. So that's the basic operation we need to do. But we need to repeat this process that once this is done, now I am at parent location. So this is a smaller goes down. That is this part. The parent goes down. But now from this position, we need to check with the parent. So my new location is a parent's index. This is my new location is updated. So we need to repeat this process. So it should not be just if, it should be repeated until I reach at the root. So which means as long as index is greater than 1, index 1 means a root. If I'm not at the root and my parents are still smaller than new data, just do the swapping process and the climbing up the tree. That's what I need to do. Then when this while loop is ended, now store the new data into the vacant slot. So that is elements index. Now I'm at the location where the new data should be stored. So that is the process of push in heap. So we can test this one. So let's make file a.out or ea.exe. heap.o is separately compiled. Main.o is separately compiled. And put together heap.o I can create by compiling heap.cpp, which include heap.h. So compile this guy only, pp. And the main.o I need to compile main.cpp where heap.h is included. So let's make a file and then go to the main function. So push 10 and then should be n should be 10. That's the one just to push it. That's the only data. So let's include C assert. There. So let's take care of a pop later. Now if I do push 20, then the top value, let's do one by one. So copy those two lines. Now it should be 20. Now push 5, then top should be still 20. And then if I do push 25, now new top should be 25. Always the largest value should be on the top, and it should be read as like that. So let's open terminal, compile, and run. All those assertions are good. So it seems a push operation works okay.